Okay, and we are back for the actual lecture portion of today's class. Again, if you were having trouble getting code blocks to work with the GCC compiler, make sure to look at the other video from today. All right, now what we're going to do today is we're going to talk about flow control. And flow control in C offers two types, like most languages do. We have decision statements, like the if statement. If you're coming to this from Python or any other language, I'm sure you're familiar with the if statement. But there are some other options in C language as well that we'll look at. And then also looping statements. So basically decision statements allow us to decide whether to do something or not do something, or do one thing or another thing or maybe another thing. Looping statements allow us to repeat something over and over again. And those are really powerful things to be able to do. In fact, it's hard to write a program or an algorithm of any complexity without decision statements and looping statements. Now, a lot of these are going to seem familiar to you if you've come from a different programming language, which all of you should have been exposed to these in Python or JavaScript or Java or some other language. But even the familiar ones in this are going to work a little bit differently than you're used to. All right, so let's go ahead and dig in. Let's start off with decisions. So decisions, the first one is an if statement. So essentially, one of the things to remember is that white space isn't important in C. So if we have this if statement like this, if something that's going to be our comparison or our conditional value, if that evaluates as true, then it will execute just this one statement. The statement 2 over here has nothing to do with the if statement. So even if we put it on the same line, the second statement is not associated with the if. So in other words, what the if statement does is it only decides whether or not to run the next statement or to skip that next statement. So it's only one single statement, and that's going to be important for us understanding it. Now, the other thing is the thing in the parentheses after this. We'll take a look at that more closely later. But notice we needed to put the parentheses, the thing inside, that's part of the syntax, not like Python where you just have a space. We have to put the parentheses. And the thing inside of here, all that matters is if it evaluates as 0 or something other than 0. And we'll talk a little bit more about that in a second. So if we have this line like this, it says if statement 1, statement 2, only statement 1 has anything to do with the if. Statement 2 is on its own. Even if we put them on the same line, even if we indent this, statement 2 is not associated with the if. It'll happen every time, no matter what. Okay. Notice that you can also do an if some statement and an else some statement, but again, the else clause is a single statement. Just like the if part is a single statement, the else clause is a single statement. So again, only a single statement is associated with either of those two parts of that if statement. Now, back to X, notice that the thing that's inside the parentheses here can be anything. It could be an expression, it could be a variable name, it could be some sort of comparison operator, it could be just a number. It could be anything that we want to put in there. The only rule is it has to be something that produces a value of some sort. And what is considered false is anything that produces a value of 0. Anything that's non-zero is considered true. So in other words, if you're used to a language like Python, where you have these special true and false like values that are kind of built into the language, there is no such thing in C language as true and false. It's either 0 is false, considered false, or it's something else which is considered true. So if you have a negative number in here, that's considered false. If you have a positive number in here, it's considered false, or true, I mean. So if you have a negative number, it's true. If you have a positive number, it's true. If you have any number, a floating point number, it's true. The only way this is considered false if it's a 0 value. That's the only thing that's considered false. Anything else is true. Okay. Now, typically what will go in there is some sort of comparison, which uses one of the comparison operators. And those are listed here. So they always will separate two things that you're comparing. Is this variable equal to this value, or is this expression equal to this one? So we have equal, not equal, less than or equal, greater than or equal, less than, and greater than. Typical comparison operators, similar to other languages. But one of the things that makes these different is that they don't produce a true and a false as a result. They produce a 0 if the result is false, it produces a 1 if the result is true. And since the if statement, the part in parentheses, only cares if the value is 0 or not, we can use that as a stand-in for true and false. But these operators do something kind of mathematical in that they result in a value of either 0 if it's false or 1 if it's true. All of them produce that resulting value. And then that can be placed in the if statement because all the if statement cares about is 0 is false. Something other than 0, in this case 1, is considered true. Okay, quick bug warning here. Let's take a look at this code here. In x equals 0, that's creating an integer variable x that we're assigning an initial value of 0. Notice you can do an initialization right there in the declaration line. And then we're saying if x equals 0, print f 0, else print f not 0. Now, a novice C programmer might look at this and think, okay, well, x we set to 0, and then we said if x is 0, which it is, we'll print out 0. But what gets printed here is not what we would expect. So the thing to note is the thing in parentheses there is not using, let me back up a second, this double equal sign. It's using a single equal sign. And that's allowed. We can put an assignment in there. That's okay because that's a statement, and it actually produces a value because the result of any assignment is the value that was assigned. So this is actually going to produce a value of 0, which is false. So we're going to get not 0. And that's something that that means that every time this code is run, it's always going to say not 0. And this is why this is a bug warning, that a programmer might say, why is it saying not 0 when I'm putting a 0 in it and I'm checking to see if it's 0? Now, one of the things as you get used to programming in C, or by extension C++, anytime you see an if statement or any of the flow control with a single equal sign inside of it like that, that should kind of set your programmer spidey senses tingling because that's probably not what was intended, but notice that the language allows it. Again, C language's motto, trust the programmer. They say, well, maybe the programmer wants to do an assignment inside of the if statement, then check what the value of that assignment was. And so we've got to be really cautious about that. And generally, I think it's good practice to avoid putting assignments in if statements just because it leads to the confusion of something. But as I'm looking through code, if I ever see this in the C program, that'll immediately attract my attention. I'll be like, that is probably a problem. That's probably a mistake there. And it doesn't matter if it's 0. If I said if x equal 1, single equal sign in here, then it's always going to evaluate as true because it'll be the value of that, no matter what was an x. And not only that, it'll replace whatever value was an x with some other value. So what gets printed? Not 0 every time. In fact, no matter what we put in for x here, it's going to print not 0. And no matter what we put in for x, it's going to overwrite that with a 0 by the time we're done with this. So again, that's a bug warning. That's a common mistake. The compiler will let that happen because, hey, that's a valid statement that you're compiling into this inside of the if statement. And so just be cautious about any time you have to see that single equal sign in a flow control statement like that. And I would say that since that is a source of bugs, that Python purposefully disallows that. You can't do an assignment inside of an if statement. The language doesn't allow it, but C, being a systems programming language, trusts the programmer. They say, you know what you're doing. If you want to do that, I'll let you. But just be cautious about that. Okay, now let's go back for 1 second here. Notice that single statement thing might seem like a limitation. Like, well, how much can we do with one single statement? But it turns out there's a way around that. And to get around the single statement limitation, C allows the grouping of multiple statements using what's called a statement block or a code block. And essentially what you do to do that is just use curly braces. So what curly braces mean, they're not really part of the if syntax. They're just a way to say, hey, this next list of statements, this group of statements between the open curly brace and the closed curly brace, treat those as if they are a single statement. And the reason for that is, or what that allows us to do, is now have the if statement tied to multiple things with this code block. But notice that code block has nothing to do really with the structure or the syntax of the if statement. It's just a way to say make a group of things that all act like one statement. In fact, we could take the if out and just put curly braces for no reason in our code. And the compiler is totally fine with that because you're saying group these together as if they were one. All right. Now, another bug warning related to that. Notice that there's a case where you see programmers write something like this. And this is especially true if you come to this from a language that uses white space, like Python. You might say if x equals 0. Notice I did use the double equal signs here, so this is correct. And I say print true clause, and then else print no, and then print false clause. And notice I have these indented like this, and then we print f done at the end. So the mystery here is what gets printed? Well, the novice C programmer would look at this and say, well, since x is equal to 0, it'll print out true clause, and then it'll print done. But what really gets printed is true clause, false clause, done. So how does false clause get printed? Well, remember that the if statement only cares about, and the else clause, they only care about a single statement. And we're not using curly braces anywhere in here. So this is going to say if x is equal to 0, which it is, so that's true. That produces a 1 from that operator. And the if statement says that 1 is true, so it's not 0, so it's true. So it prints out true clause, and then it skips over the else, which was printing out no. But then this false clause has nothing to do with the else at all. Even though we indented it, it has nothing to do with that. It's only the single statement here, which is just no. So we get true clause, and then after the else, we get false clause, and then we get done. So the problem there is that line, that printf there, is not part of the if statement. It's after the if statement. And the indentation has nothing to do with how the compiler interprets it. Even though we've indented it and made it look like it's part of that else statement, note that it's not. Now, and let me back up for just a second. One of the things that I like to do when I write C code is I'll use curly braces kind of gratuitously. So if you only have one thing it's doing, you don't need it, but I'll put them there anyway. So I would still put a curly brace, printf true clause, close curly brace, because it adds clarity to the code. So even though it's a little more typing, it adds clarity. And if somebody goes back and wants to add more stuff later, for example, this else, somebody tried to turn it from one printf into two. If the curly braces are already there, you don't have to worry about them recognizing, oh, that's a single statement. I got to add a code block here, or a statement block in order to do that. Okay, you can also nest if statements with or without the curly braces to any level you want. Here's an example of a minimum function that I give three things to, three integers to, and it's going to return to me the smallest of them. So basically, if a is less than b, then we know that b is not it. So we have to decide, is it a or c? So if a is less than c, then it's a. Otherwise, it has to be c. And then if a was not less than b, then we know that a cannot be it because it was greater. So it's between b and c. So then we just say, is b less than c, return b. Otherwise, return c. But notice I've nested an if statement inside of an if statement. And notice I didn't need curly braces, even though I have multiple lines here, because this if statement says, what's the use the next single statement, which is this whole if statement down here, which includes an else clause. And that's okay. So this code is actually correct without curly braces. Maybe we could add them to add some clarity if we wanted to, but this will work fine because there's only one statement in the if clause and one statement in the else clause, and that statement has its own if and its own else, but it's still considered one statement. All right, bug warning with nested if statements. Here's an example of kind of a stripped down version of that previous one. I don't really know what the function of this code is, but notice I'm passing in three numbers, a, b, and c. And I'm saying if a is less than b, then I go in here and I say if a is less than c, then print a. So in other words, a is the smallest at that point. Otherwise, we're saying print c by the way that we've written this code. So if I pass in 10, 5, and 2, what gets printed? And you might think, well, let's look at 10 and 5. So a is 10. So 10 is not less than b. So we should take the else clause and print c. But what gets printed? Nothing. Nothing gets printed when we call this function. And that seems like mysterious. Well, I know that 10 was not less than b, so it looks like I should take this else and print c. But the problem here with nothing getting printed is that else here, this else statement, goes with the most recent if statement. So in other words, this else has nothing to do with this first if statement. It goes with this one. And this is actually a thing called the dangling else problem in programming. That, for example, this else, which if statement does it go with? Does it go with that one or does it go with that one? And notice the indentation level leads us to believe this if and else are together, but it's really these two here. This inside if is what that else goes with. And so the rule is that the else goes with the most recent unmatched if statement. So else, I scan upwards, there's an if statement without an else, it goes with that one. So that else goes with this if. This if has no else, which is why nothing gets printed. So it says if A is less than B, which it is not, then we skip over all of this and do absolutely nothing. All right, so that's another bug warning. And again, gratuitous use of curly braces around those parts of code would have solved this problem. But keep in mind that any else goes with the most recent if statement. Okay, notice you can also use else if statements. So if x equals 0, then print A. Else if x equal 1, then print B. Else if x equal 2, print C. Else print F none. So in other words, this is more than just two choices, more than if and an else. But one of the things to note is that the else if in C does not use a different keyword like other languages. In other words, in Python you have this elif special keyword for the else ifs. But in C, it uses else and then a space and an if. And the reason for that is because remember what the else does is it uses the next statement, single statement after that. And in this case, the next single statement is another if. And then that one, now this else goes with that one. So if this didn't match, then it takes the else and runs the next single statement, which is another if. And then that else goes with that one. So in other words, this makes sense. The compiler will make sense of it. But notice that really what we're doing is we're saying this if has that else, this if goes with that else, this if goes with that else, and then finally we get to that. So anyway, it'll still filter through this and find the first one of these that matches and produces a true. It'll take that, and then because the rest of this is an else, it'll skip over all the rest of it. So in other words, having this if, else if, else if, else if, as many of them as we want, followed by an else structure, it'll take one of these paths, the one that matches, and if none of them match, it'll take the else clause at the end. Now, C does offer another method to do things like this that's really useful. This is something that I wish a language like Python actually had, and that's called a switch statement. And the way the switch statement works, it has this completely separate construct that works like this. We say switch, in the parentheses we put something that has a value. So this could be, for example, switch level or switch whatever we want. And then what happens is we say the word case, and then we put the value we want to match with that. So in other words, it'll execute the lines associated with this case 1 label if the value, if this variable matches that value, or this expression matches that value. And it will do this one if this matches that value. So in other words, this gives me the ability to say is value 1, do this. If value is 2, do this. If value is 3, do this. Now, one of the things to note is the need for a break statement at the end of each of those cases. And what the break does is it'll, in other words, when value matches case 1, it'll do this, anything that's in here, and then when it hits the break will jump out of the switch automatically. Also notice that you can have a default, which is essentially equivalent to an else. So if none of them matched, it'll take the default case, which you just use the keyword default, colon, and then anything we have down here. Now those breaks in there are important, and let's talk about why. Actually, I missed, there's a page missing here, but let me explain something while we're on this one. A slide somewhere. But essentially, these breaks are necessary. And the reason they're necessary is because what happens in C language is if you leave out the break, it'll fall through to the next case. And if I leave out that break, it'll fall through to the next case. So in other words, you have to have the break, and otherwise it'll fall through. Now, that's by design. Actually, when they were creating the language, Dennis Ritchie and Brian Kernighan had some sort of a conversation about this, and some sort of, do we make it so it falls through the cases without the breaks, or we make it automatically so we don't need the breaks? And they opted to have it fall through. And the reason they did that is that allows you to actually stack multiple cases up on top of each other. So you could have case 1, case 2, case 3, and have shared code between those multiple cases. And because of that, that allows you to do some useful things where you can have, hey, take this one single action, when this matches 1, or it matches 2, or it matches 3. So that, for example, you could have something like, if the case is uppercase A or the case is lowercase a, then we take this function to move left in our game or whatever. If the case is capital W or it's lowercase w, move forward. And so that allows us to have multiple cases that stack. There's also some really clever stuff you can do with that fall-through behavior of case statements. For example, there's an optimization technique called Duff's device that relies on the fall-through behavior of case statements. I'm not going to talk about Duff's device right now, but if you're a programming nerd and you haven't heard of Duff's device, I'd encourage you to look at it. It's this really clever method of unrolling loops that uses the fall-through ability of case statements to handle any loop size rather than having it be a multiple of some size. But take a look at that Duff's device thing if you're interested. But that takes advantage of that fall-through behavior of case statements. Okay, the while statement. We're off into looping statements now. So what the while does, it works a lot like an if. You just use while. And again, it just does the next single statement following the while statement. And again, x, the thing in parentheses, is anything that produces a value. And all while cares about is 0, it's false, it stops the loop. If that's something other than 0, it continues the loop. So if we want to do more than one thing, we still use curly braces to make a statement block or a code block. And it will repeat this code as long as this comparison or this thing in parentheses comes up to be non-zero. In other words, it'll keep doing this while this is non-zero. Now, there's another type of while loop that's worth looking at. Before you do that, think of a while loop as like an if statement that does the stuff in here, but then it jumps back up and tests it again. Does the stuff inside, jumps back up and tests it again. All right, there's another kind of while loop, though, that's going to, maybe you've seen something like this before, but it's called a do while loop. And the way it works is you say do, then you have a single statement, and then a while some condition is true. So in other words, this is like a while loop that's been flipped upside down. And the version of that uses a code block, here it is here with the curly braces, but you say do, list the things you want to do, and then the while afterwards. Now the only real difference between this and a while, traditional while that looks like this, other than the way the word do at the front and the while at the end, is that this one is guaranteed to run the loop body at least once. In other words, it'll come in, it'll do this once, and then it'll check the condition to say, do I need to repeat it another time? So in other words, this version is like, if this is false, it'll skip over it and we'll do it 0 times. This one will always do it 1 time and then maybe go back and do it again. So the traditional while loop is to do something, repeat something 0 or more times. The do while construct allows you to do something 1 or more times. And it's always guaranteed to run it at least once. And there are a lot of cases where that could be useful, where you'd have to come up with some convoluted logic to make sure something like this ran at once. But here, it'll naturally always run the code inside the body of the while loop at least once, and then decide whether to repeat it or not. All right, the next one is a for loop. And again, if you know Python, the understanding how for loops work in Python will absolutely not help you with understanding how they work in C or C++. Maybe some other languages would be helpful, but not Python. So this works completely different than you're used to. So here's how it works in C. In C, we have the word for, and then in parentheses, we've got this thing with 3 parts that are all separated with colons, or semicolons, I mean. So we have an expression 1, a semicolon, expression 2, semicolon, and an expression 3. So in other words, the for loop has kind of 3 expression clauses inside of the parentheses. Now, again, that single statement thing, we can always make a code block or statement block for that to have multiple statements there. But to understand how the for loop works, it comes down to understanding what these 3 expressions mean that are inside of here. So let's take a look at that. All right, so here's our for loop structure. So expression 1, the one before the first semicolon, that's evaluated before the for loop begins and starts repeating things. And that only happens once. It's only executed once before the loop gets entered and starts repeating things. And generally what that's used for is some kind of assignment statement. Like, for example, you might say for I equal 0, which would and then the semicolon, which says for assign the variable I to 0 to start it at 0. So it's usually used for initialization things, to initialize a variable for the loop or assign a variable for that's going to be used for counting through the loop. But it could have anything in there that we wanted to. It's just any expression there. It's not even tested for is it true or is it false. It just executes that, evaluates that before the start of the loop. And it only happens once before the loop starts up. Expression 2, the middle one, is considered what I like to think of as the while clause. So think of that as a while. And that expression determines if the loop will execute or not, a lot like a while loop. So if this is false, none of this will happen. If this is true, it'll enter the loop, just like with a while. And usually that's some kind of comparison, a conditional that produces 0 or non-zero, but it could be any expression that produces a value, just like a while loop. So normally it's something like x is less than 100. And then expression 3, the last one, that happens after all of the statements in the loop have been executed before it goes back and tests the expression again. So after each loop cycle is completed, expression 3 gets evaluated, and that's usually an increment or a decrement or something that adds to some value to go to the next thing in a sequence or something like that. And notice that the way you would read this is for example, an example would be like for I equals 0, while, and then in here, I less than 10, and then I plus plus, or less than 100, I plus plus. So by plugging in I equals 0, semicolon, x, maybe I should say I less than 100, semicolon, I plus plus in here, that would make a for loop that goes through and repeats the statements in here until this while loop is, while expression, the middle expression is no longer true. Now, one of the ways that I like to think about this, or I like to explain this, is that a for loop is really the equivalent of a while loop, but it kind of gathers important things together here all at the top. So in other words, rather than having something before the while loop and then an expression in here and then something at the bottom of the code, it kind of gathers the important parts up here. So in other words, a for loop like this, for expression 1, expression 2, expression 3, that could be replaced with a while loop that again has expression 1 evaluated before the looping part. Expression 2 is the while clause that causes it to continue, and then we have our multiple statements, and then expression 3 happens at the bottom before we go back up and test the expression again. So any for loop can be replaced by a while structure like this, but notice in the while structure the problem is all three of these things are kind of spread out from each other, where it can be convenient to have them all placed together like that. And let me just pause there for a second. I'm going to switch over to show a quick example here. And if you're, remember, we had looked at this website. Here, let me switch over so you can see what I'm doing here. We'd switched over to this website called this online GDB, which is an online C compiler. So let me click on that and go to that. And let me just show you a for loop in action here and show you that that's equivalent to while. So I'm going to make an integer variable. I'm going to call it I. I'm going to go and make this for loop, and I'm going to say for parenthesis I equals 0, while I is less than, let's just do 10, semicolon I plus plus, which we haven't really talked about operators. We'll do that next class. But notice plus plus is an increment. It's the same as saying I equal I plus 1 or I plus equal 1. I'll put parentheses there, and I'm just going to do a printf. I'm going to say I is colon %d \n for a new line. And then this is a format specifier for decimal integers. I'm just going to plug in an I there and then put semicolon there. All right, so notice this is just going to go through and repeat this code, start I at 0. So the first thing we should see is I is 0, and the next line I is 1, and I is 2, and I is 3, and so forth all the way till we get up to the last one. So let's run this and see what the output is. We run that. I'm getting an error here. Oh, somehow I didn't have my I equals 0 there. Okay, So there we go, and notice it went through. Let me move this up a little bit so you can see the output. And notice the output was I is 0, I is 1, I is 2, I is 3, 4, 5, 6, 7, 8, 9, all the way up there. And let me, for clarity, let me just add a space in there for my format string. All right, so there we go, 0 through 9. Now notice that I can get that same behavior, so I'm just going to comment out this part of the code, and we're going to replace this with a while loop that is built doing the same thing. So here, remember we said that this part here would be before the loop. So I'm just going to copy that, move it down here. That's the part before the loop. That would be expression 1. And now we have the while part, so while. And then this is going to be expression 2, which is I less than 10. So I'm going to plug that in there. And now we have the body of the loop, which is going to be the same as what we had up here. So I'm just going to copy this line, put it in there. And now we have expression 3 is going to go right here. And expression 3, remember, was just I plus plus. I'll just type it. It'll be faster than copying and pasting it. Expression 3. All right, so there's my version of this code written as a while loop rather than a for loop. I need to take one of those out. All right, so notice that's the same thing as what we had up here. You remember it went 0 through 9. Let's run it again and see what behavior we get. 0 through 9. So the same thing. So in other words, a for loop is really just a while loop that has these parts done for us. But notice the advantage for this is when we use it as a for loop, and let me put this back in and comment out the second one now. Let's put that in. Let me comment out this down here. Notice the advantage of that is that all the stuff manipulating this variable I is all right here at the top of the loop. We're saying for start I at 0, run while I is less than 10, and increment I every time. We don't have to hunt down the different parts in different parts of the code. So it's a better way to deal with things that need to count or index through things or increment through some stuff. And we're going to see a lot of uses for that later on in the class. All right, let's switch back to the presentation here. Okay, so back to what we were doing. We now know how the for loop works. And one thing to note is that you can omit any of those expressions that you want. So you still need the semicolons in there, but you can omit them. So for example, if I leave all of them out, that creates an infinite loop. In other words, there is no while part here. It defaults to being true or running the code. So if I leave that out, and I could leave the first one out, or the middle one, or the last one, or any combination of those, I could leave them out. But notice that what that's going to do, backing up a step, it'll just be like this expression didn't exist, or this is replaced with a 1, it's always true, or this expression doesn't exist, but you can leave those out, and that's totally fine with that. But you need to have the semicolons in there. Okay, another quick bug warning here. Here's some code. Int x equal 2, so we're creating a variable x, assigning it the value of 2, and now we're saying if x equals 0, and I use the double equal, so that's not the problem here. And then I say set x equal to 1. So the question is, what is the value of x after that code runs? And so your initial thought might be, well, x was 2, it's not 0, so it's going to skip over this, so it should still be 2. But it turns out when we run this code, and actually let's just look at that. So what is the value of x after the code runs? Well, the answer is x will contain a value of 1. Well, why? And the answer to that is something that, again, C languages desire to trust the programmer. Remember that the if statement only executes a single statement following the if statement. And notice there's something weird there. There's a semicolon that we stuck at the end of that line. And so that extra semicolon, a semicolon by itself, is considered the null statement, or still a statement. It's just a statement that does nothing, kind of like pass in Python if you're used to that. And it becomes the body of the if statement there. So watch out for if statements or while loops with that semicolon on the end, because that can trip you up, because the code looks right. There's a one single extra character there, but that means that this if statement has nothing to do with this code that follows it. And so C allows an additional code block to be created here. We're just saying, hey, if x is equal to 0, then skip over which it's not, then skip over doing nothing, and then run this code block which sets x equal to 1. Now, another example. Same problem. We say int x equal 11, while x is greater than 0, x minus minus. So you might think, well, this is going to start x at 11, then it'll go to 10 and 9 and 8. It'll decrement down through all the way till we get to 0, and then this while loop will stop. So the question is, what's the value of x after this code runs? And this one might have an even more surprising answer here, but the code will never finish. It'll get stuck. It'll run forever. In other words, we're going to run this code and we're going to enter an infinite loop and never get out of this while loop. All right, why not? And the answer to that, again, is that extra semicolon there. That extra semicolon by itself, null statement. In this case, we're saying, hey, while x is greater than 0, which it is because it's 11, run and do nothing. So that semicolon counts as the body of the while loop. So we're saying, hey, while 11 is greater than 0, do nothing. And x is always going to be 11 because nothing in this null statement is going to ever change it. We're going to get stuck here forever. So again, watch out for those semicolons at the end of any of the flow control structures, while and if. Just like the single equal inside of one of those should set your Spidey senses tingling, your C language Spidey senses, a semicolon at the end of something like a while loop can also, or should also do that for you. Now, sometimes you want to have an empty body in a while loop. And what I would suggest doing if you want that, rather than just putting a semicolon like that, put curly brace, semicolon, curly brace, because that makes it very apparent that you meant to do that. Okay, two other statements quickly here. Break and continue. Those do the same thing they do in other programming languages, meaning that if when it encounters a break inside of a loop or a switch, it immediately exits that loop or switch structure. If I have a continue, it immediately goes back to the top of the loop structure and tries again. So again, those are similar to what you've seen in other languages, probably Python, Java. But note that you can use those if they're encountered. It just causes it to immediately exit a loop, immediately go back to the top of the loop. Now, the next thing I'm going to look at is something that you probably shouldn't use very often, but it's part of C language, so I'm going to explain it to you. And I've used this before, and there are cases where it's a very useful thing to know, because there are cases where this is a good thing to have in certain situations. But you have to know what you're doing. So in other words, don't use this if you don't have a good reason to. And that is the goto statement. And what the goto statement is, it basically makes the code jump from one place in the code to a label that's defined somewhere else in the code. So here's an example. If we say go to end, that's going to jump to the label end. And the way you make a label is you type that identifier name with a colon, and you can just stick that in your code somewhere. So in other words, when this statement gets encountered, the program is going to just jump to this other place in the code and start executing code from that location. And that label that we define could be either after the goto line, could be before the goto line, but there is one other rule with it, and that's it has to be within the same function. In other words, it doesn't make any sense to have two functions and have it jump from one down into the middle of the other function. The function has to be called from the top. But if you're inside of one function, it could be the main, could be some other function you made, you can use gotos to handle that. And one of the cases where I've used gotos a lot is, a lot of times it's easier to add error handling that way, to say, hey, if an error happens somewhere, anywhere in this function, let's just jump to the exit of the function and return an error code from that, rather than having to build a bunch of nested if statements that check, hey, was there an error? If there was, then put all this other stuff in these nested if statements. You can just jump to the thing to exit. There actually is another thing that's like goto that we'll talk about later, which allows you to have your program kind of jump from one function back in time. It's kind of like a time machine for your program. And that's called set jump and long jump. I'm not really going to talk about those now, but they're part of the standard C library. And those can be really useful, but it kind of lets you, your program say, remember this point in time, And then no matter where you are in the code, you can go several functions deep. You could be way down inside some function call chain, and you can say, let's go back in time to where it's kind of like Back to the Future in your code. And you can actually send a message from that back in time to where you called that from. I don't want to get into that now. It's just a cool thing. If you're interested, look up the set jump and long jump functions that are part of the standard library. We'll look at those later this semester. But note that goto, you cannot jump from one function to another function. And really with set jump and long jump, you can jump from one function to another function, but only by going backwards in time, sending your program backwards in time to a previous place where the set jump occurred. We'll talk about that later. That's kind of like a weird, cool thing that you might need in some situations. But to finish off goto, avoid using them unless you have a really strong reason to do so. And the reason for that, you don't want to get into the habit of using gotos and making unstructured code that if this is true, then jump back up here, and then that looks at something and it jumps down there, and you make this spaghetti logic out of your code that's really hard for anyone to follow. It's better to structure your code with nested structures whenever possible, but sometimes it can be useful to jump out of something. Another case where that can be useful is a break statement. Looking back at the break statement here, remember it immediately exits a loop or a switch structure, but it will only exit the most recent one you're in. There's no way to say break out of this loop and then the previous one, the previous one. You can do something like that by using goto statements, but don't do it unless you have a good reason. All right, last thing here, infinite loops. We already looked at the concept of infinite loops earlier with the for loop structure, but again, notice you can make an infinite loop by saying while one, because all this cares about is that something other than 0. So generally you'll have like while 1, you could say while 1 double equal 1, but this is enough to make an infinite loop. Just say while 1, and this will repeat this over and over again. Or the preferred way to do it is to do a for loop with nothing in the semicolons, and then this infinite loop code. And the reason why this for loop method is preferred is notice that the while, this 1, that has to get fetched and pulled from memory into the processor to do that comparison. But the for loop kind of defaults to repeating the thing over and over without having to load an extra piece of data into the processor. So this can generate slightly more efficient code on some compilers. A lot of compilers will detect that this is an infinite loop and it'll replace it with what this would anyway with the optimizer. But this is considered kind of better practice for infinite loops. And also keep in mind that you can make an infinite loop and the break statement will still exit them. So you can make an infinite loop that runs forever, but if it ever encounters the break statement, that'll cause that loop to terminate and jump out of that loop. Okay, so that's pretty much all I wanted to cover today. I want you to be prepared for a quiz on the next class. And again, if you're having trouble getting code blocks to work, look at the other video from today. And I guess the second part of that, if you're having trouble getting code blocks to work, I noticed that on Macs, on the code block site, there's a problem with that the newest version of Mac will only allow 64-bit apps. The code blocks app for Mac was compiled as a 32-bit. So you may have to use a different development environment if you're programming on Mac and you have the latest version of that. But if you're having trouble with it on the PC or on Linux, send me an email, send me a text message, however you want to get a hold of me, get a hold of me. I can come down and meet you at my office and I can help you get that up and running, but look at the other video first and make sure you look at that. All right, that's it for today. Everybody stay safe, and next class we're going to have a new lab. We're going to have some lab time, and we're also going to dig into some of the operators. We've seen a couple of them today with plus plus and minus minus. We're going to go through the set of C language operators, and then you're going to have a new lab, and also be prepared for a quiz. All right, that's it. So everybody stay safe, wash your hands, and I'll see you next time.